Hello students, this is Mrs. Williams from Tyler Legacy High with another episode for our studies on segment addition. So if you remember, the segment addition postulate says that if you have three collinear points, then one of those points is between the other two, and the two segments that are formed are equivalent to the total segment. In other words, the part and the part is equal to a whole. So in this case, what we have is that the first part of the segment, AB, is equivalent to 3x, and the second part, BC, is 2x. So our segment addition postulate says that AB, the length of segment AB, plus the length of segment BC is equivalent to the length of segment AC. We're going to substitute in. AB is 3x, BC is 2x, the length of AC is 15. We're going to solve. Simplify, and now we'll solve by dividing by 5. The value of x is 3. So in other words, the length of this segment is going to be 3 times 5 is 15. 3 times 3 is 9. And 2 times 3 is 6. And 9 and 6 is 15. It checks out. Let's look at another example. We have segment CE, and it's divided into two parts. These are three collinear points, and the segment addition postulate says that one point is between the other two, and the part and the part equal the whole as far as the segments are concerned. So segment CD plus segment DE is going to equal to segment CE. Let's substitute in. The length of segment CD is x. The length of segment DE is 3x plus 1. And the length of CE is 17. We have 4x plus 1 when we simplify. Let's solve the two-step equation. 4x is equal to 16. Divide by 4. X is equal to 4. So in other words, the length of CD is 4. The length of DE would be 3 times 4 is 12, plus 1 is 13, and 4 and 13 does give me 17. Let's do another example. In this case, we have three collinear points, U, V, and W. V is in between the other two. So the segment addition postulate says that UV plus VW is equal to the length of UW. So we're going to substitute in. UV is 2x plus 5. VW is 4x minus 3. And the total length is going to be a missing number. And that missing number is 44. Okay, we're distributing a 1, and we know that that doesn't change anything. So the parentheses really here are not needed. 2x plus 5 plus 4x minus 3 equals 44. We're going to combine our like terms. We get 6x plus 2. The signs are different, so subtract. Take the sign of the larger. We're going to subtract 2 from both sides. we get 6x is equal to 42. And when we divide by 6 on each side, we get x is equal to 7. So in other words, on the left-hand side, 2 times 7 is 14 plus 1. This length here is going to be 19 units. And 4 times 7 is going to give me 28 minus 3 is going to give me 25. And 25 and 19 does give me 44. One last problem. And let's separate this so that we're not distracted. We have 3 collinear points, x, y, and z. The segment addition postulate says that if you have 3 collinear points, one of those points is between the other two, and the 2 segments that are formed have the same length, or added together have the same length or equal length to the whole. So we have that x, y plus the length of segment y, z should be equal to the whole, which is x, z. And we're going to substitute in. We have 7x minus 8 added to it, 2x minus 5, and the total length is 59. We're distributing a 1, which is our multiplicative identity, so the parentheses are not needed. Okay, 7x and 2x is 9x. A negative 8 and a negative 5. The signs are the same, so you're going to add. If you take the sign of the larger, that will work. We're going to solve the two-step equation. 9x is equal to 72. Divide by 9. Oops. Divide by 9 on each side. So x is equal to 8. 8 times 9 is 72. So when we come over here, and we can just double check this. 2 times 8 is 16, minus 5 will give us 11. And 7 times 8 is going to be 56. So when we subtract 8, what would that give us? 48. And that gives us 48. And 48 and 11 gives us 59. You're now ready to do the next section, section 3, on the guided practice for segment addition postulate. Thank you.